Hello guys, today we will continue the discussion on principle of moments. So this topic, yung principle of moments, is also referred to as the Varignon's theorem. So it states that the moment of a force about a point is equal to the sum of the moments of the components of the force about the point. So ito guys, pareho lang nung na-discuss last time, no? Wherein you break down the force into its components. Okay. If you will notice dito sa figure, okay, so we have point O and force F acting at a distance y and x from O. No? So, di ba, from the previous discussion, yung moment arm or yung D is perpendicular distance ng force dun sa point kung saan iikot. Okay? So, if we will extend this line na parallel dun sa force, okay, we will find this to be the moment arm. Okay? So, itong D na to. But then, minsan kasi hindi naman siya ganun kadali kunin. Okay? So, kaya what we do is we break F into its components, Fx and Fy. That's why we have Fx times yung perpendicular distance from O, which is y, and Fy times the perpendicular distance, which is x. Okay, so this method is generally easier than finding the same moment using MO equals FD. Okay. For this problem, meron tayong member, or tas naka-incline siya ng 30 degrees from the horizontal, and one end of the member is fixed, so that is point O, and the other end is free, tapos may 5 kilonewton force that is being applied. Now, the 5 kilonewton force is 45 degrees below the horizontal axis. So, ngayon, pinapahanap is yung moment of the force about point O. So, what do? We just copy the figure, and then we are to break the 5 kilonewton force into components. So, meron tayong Fx and Fy. Now, kapag meron na tayo niyan, madali nang kunin yung moment about O. Okay? Kasi diba, moment is just yung summation of forces times their respective distances dun sa point kung saan iikot. Okay, so, M, the moment about O is equal to, so we are, dito sa first term, we are considering yung x component, so that is Fx times D. Okay, so negative kasi yung magiging pag-ikot ni Fx about O is clockwise, kaya negative. Okay, and then Fy, same, it will produce a clockwise rotation, kaya negative din si Fy. Okay, substituting values, yung x component ni 5 kilonewton force would be negative 5 cosine 45. And then, yung distance, ito. So, ito yun. Itong distance na to, ayan. Okay, so, yan yung kailangan natin, distance ni Fx kay O. So, that would be 3 sine 30 degrees. Okay? Kasi ito ay opposite nung angle 30. Okay? And next, for the y component, we have 5 sine 45 times yung distance na, ito naman yung distance. Okay, so yung distance na yan. So this distance here is equal to 3 cosine 30. No? So 3 cosine 30. Okay? Now solving, you get M sub O equal to negative 14.489 kilonewton meters. Okay? As what I have told you, lagyan nyo ng direction. So, instead of writing negative 14, our final answer will be 14.489 kilonewton meters clockwise. Okay? So, ayun, ganun lang siya. Another solution is to find the perpendicular distance D from O. Ayan. So, pinakita dito na yung F daw is 75 degrees from this member. Okay? Ngayon, kung gusto mong diretsong 5 kilonewton force, multiply mo sa distance, dapat hanapin mo to, yung D na perpendicular dun sa line of action ng force papunta kay O. So, ang magiging value ng D na to is, ayan, since ito yung hypotenuse natin, 3, so 3 sine theta, or 3 sine 75. Okay? Kasi ito yung opposite ng angle. Alright? So, the moment at O, about O, would be F times D, so that is negative 5, kasi yung 5 magiging clockwise din yung rotation, di ba? Kaya negative 5 times yung na-solve natin na D, which is 2.898. So, ang makukuha mong sagot dyan, ganun din, negative 14.489 kilonewton meter. Ngayon, nilagyan ko na lang ng direction and then I removed the negative sign. Kaya 14.489 kilonewton meter clockwise. Okay, so that's for this problem. Ayan. Next, we have this. Force F acts at the end of the angle bracket. Determine the moment of the force about point O. So, ayan. Ganon din, i-break mo din lang into components, si F. So, that would be, so, kunin mo yung X component and yung Y component. Okay? So, let's first solve the, express yung X component ni F. So, that would be 400 sine 30. Okay? Kasi, yung X component is opposite of this angle. Okay? Kaya, 400 sine 30. And then, distance ni X. So, ito si X, diba? Ayun. So, distance niya is 0.2. Okay? And si X ay magkukos ng counterclockwise rotation about O. Kaya positive. Next, Y component ni 400 Newton force. So, pababa yun, diba? So, yung Y component is 400, negative 400 cosine 30. Okay? Cosine kasi adjacent side yon. Right? So, ayun, negative kasi ang rotation ay clockwise. And then, yung distance from O is ito, 0.4 meters. Solving, you will get negative 98.564 Newton meters. Okay? And to express, yung ating final answer would be 98.564 Newton meters clockwise. Okay? So, yan. Of a simple distributed loading. So, example dito, you have a beam, fixed yung one end, and then naka-roller support yung other end. Tapos, meron daw siyang distributed load sa taas. Pero, uneven yung distribution. Ngayon, paano daw natin kukunin yung resultant force? So, ideally, tayo ay mag-integrate. Okay? So, calculus, ano? Ayan. Sinasabi lang dyan na yung summation, yung resultant force would be the integral of this area here. No? Yung area na to. Okay? So, tapos yung X bar or yung location ng resultant force would be the integral of x dA over the integral of dA. So, ano lang, to better illustrate, we have the following problem. Ayan. So, for this problem, sabi, a distributed loading of P equal to 800x pascals acts over the top surface of the beam. Determine the magnitude and location of the equivalent resultant force. So, yung 800x pascal, nag-a-act siya dito dito sa buong ito. Ito. Ayan. Baka, yung buong yan, guys. Okay? So, parang naka 3D siya, no? Ganun. Ngayon, paano natin kukunin yung resultant force? We are going to kind of simplify. So, from 3D, gawin natin 2D. Okay? So, yung 800x pascal, yung width niya is, ito, sabi, 0.2. Kaya, when we multiply 800x by 0.2, we will get yung load na, kumbaga, nasa gitna. Ito, nandito na yung loading. Okay, pag ganyan na siya, 2D na siya. Okay, parang ito na yung itsura. Okay, so we can look at it na naka 3D. Naka 2D. Okay, so multiplying 800x by 0.2 meter, we get 160 x Newton per meter. Yung unit kanina, guys, ay Pascal. Okay, so Pascal is Newton per square meter. Okay, so Pascal is equal to Newton per square meter. Dahil nag-multiply tayo ng 0.2 meter, ang unit natin naging Newton per meter na lang. Okay? So, yan. Ngayon, meron na tayong triangular na distributed load. Okay? Tapos sabi, from here, 7,200 Pascal yung maximum load yung nandito. Ngayon, yung 7,200 na yan, pag minultiply natin ng 0.2, we get 1,444. So, yung max value dito ng triangular load is 1,440 Newton per meter. Ayan. Ngayon, paano natin kukunin yung resultant load? Okay. Itong triangular load, we are going to parang pagsasama-samahin natin, parang ganon, no? To express this distributed load into one force, yung resultant force na nga. So, how do we do that? Kukunin lang natin yung area nito, yun na yung magiging value ng ating resultant force. Okay? So, ayan. FR is equal to, ano ba yung area ng triangle? Diba? That's just 1/2 times base times height. So, meron tayong 1/2 times base na 9 times height na 1,440. We get a value of FR na 6,480 newtons. Ngayon, to get the location of FR, kailangan alamin natin nasan yung centroid nung areang to. From our jom or trigo. Okay, yung area ng triangle, ang centroid ng area ng triangle ay 1/3 from the base. Okay? So, ayan. If this is x, okay, kung yan yung magiging measure natin, ang magiging x bar natin is 9 minus yung 1/3, no? 1/3 nung tawag dito, nung length. Okay? So, x bar is equal to 9 minus 1/3 of 9. Therefore, we get x bar to be 6 meters. So, ibig sabihin, yung resultant force natin ay nag-a-act 6 meters from the left end of our beam. Okay? So, yun yung ibig sabihin niya. Okay, so, these are the final answers. Next naman, ito, the granular material exerts the distributed loading on the beam. Determine the magnitude and location of the equivalent resultant of this load. Kanina guys, ang load natin, triangular, di ba, na 3D. Ngayon, 2D na lang siya, pero trapezoidal. Okay, so how are we going to find the resultant force? Yung trapezoid na yan, pwede natin yang i-break into two shapes, di ba? Pwede tayong magkaroon ng rectangle and one triangle. Kasi, kapag trapezoid, mahirap pa i-locate yung centroid eh. Kung hahatiin natin, gagawin natin isang rectangle and isang triangle, mas madali yung location ng centroid. Okay? So, let's do this. Now, from this figure, ayun na nga, I kind of, parang kinat or in-express into two loads yung ating trapezoidal load. So, meron tayong rectangular 50 pound per foot load and triangular na 50 pound per foot. Guys, ito 50 kasi yung triangle natin nag-start dito. No? Hindi naman siya nag-start dito. What I mean is yung kumbaga, diba, this is 100, tong point na to, and this is 50. Okay? So, dahil in-exclude na nga natin yung rectangle, we're left with 50 here. Okay? So, yung height na to ng ating triangle is 50 pounds per foot. It's not 100. Okay? Kasi 50 plus 50, that's yung 100. Okay? So, ayan. Ngayon, kukunin natin yung force. Let's say this is area 1, yung green, and area 2 yung blue. Okay? So, yung force kay area 1 is just 1/2 times base times height. Base na 9, height na 50, you get 225 pounds. Force kay area 2, that is base times height. So, base 9, height 50, you get 450 pounds. Now, to get the resultant, since pareho namang pababa yung direction nito, ibig sabihin, i-add mo lang sila. Diba? Therefore, FR is equal to 675 pounds. Ayan, may FR na. Ngayon, kukunin na lang natin yung location ni FR. Okay? So, to find the location of FR, we are to some moments about A. Let's say this is A. No? So, ayun na nga. Ito si A. This point here. Hindi naman tayo dito. Kunwari yan na si A. Now, yung resultant natin na 675, that would act at a point na X bar from A. Okay? Yung resultant force natin, yung moment na makakreate niya is equal to the moment that will be created by F1 and F2. Kaya, 675 X bar equals, okay, si F1 na 225 times 9 over 3. So, 1/3 ng length. Okay? Plus, F2 na 450 times 9 over 2. Kasi, ang centroid ng tawag dito, rectangle ay ayan, sa gitna. So, yung kalahati, no, ng length. Kaya 9 over 2. So, solving for X bar, we get X bar equal to 4 feet. Ayan. So, ibig sabihin, yung FR natin is located at a distance 4 feet from point A. Okay? So, that's all. Thank you.